Hello everybody and welcome back. We're looking at question 10 on the 2006 Fermat paper. In the diagram, two rectangles intersect at exactly 2 points A and B. The maximum possible finite number of points of intersection of any two rectangles is... Oh, look at the options we've got. 3, 4, 12, 8, 6. So we know 2 is possible. What else could we possibly have? So we can. I have a guess that the answer is probably 8. What we can do is we can, if we're not sure, we can start drawing some rectangles and saying things like, I can get 1, 2, 3, 4, and they didn't say they have to be equal rectangles, right? Yeah, just 2 rectangles. Or, well, what else could we have? Well, we could have, that's 4 again. That one's still 4. Maybe 4 is the answer. So why did I think it was 8? So here we've got 8. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. And messing around with that, I think getting 8 like that probably is the answer. I think that was D that they said. Yeah, D is 8. The question is, well, actually, 8's pretty high on the list. So if you can get 8, yeah, obviously 3, 4, and 6 are out. The real question is, can we get 12? Okay? Now, most people will play around with it a bit more and say, no, I can't get 12, and I sort of think I get why. And they'll move on, and that's great. That's a great way to do multiple choice questions. Remember, this is not a written contest. This isn't the Euclid. You don't have to justify why 12 isn't the answer. If you are pretty sure by trial and error and guess and check that 12 is not the answer, fine. I mean, it's part A. This shouldn't be hard anyway. So they're likely just intending for you to mess around. Realize, it's probably 8, move on after we bubble in D. But let's actually talk about why it's not going to be 12, or at least why I think it's not 12. And it comes from the fact that if we take a look at our 8, what's happening? Well, each side gets 2 points of intersection. And I claim that at most, any side, we'll fix one of the triangles, we'll fix one of the rectangles. Any side of rectangle A, let's call it, will have at most 2 intersection points. Okay, and you can see that this realization that if this is true, then yeah, of course you fix a rectangle A, and it's only got 4 sides, so at most 2 intersection points, 2 times 4, 8 really should be the best there, if you can even get that. So why do I make this claim? Well, it's part A, so we're not really going to go too far in depth and make a super rigorous argument, but so let's pick a side. We'll focus on, say, the purple side. So we have to we have sort of 2 intersection points here. Okay. So now these 2 points, do they lie on the same side? So our other rectangle, so we'll call this one A. Our other rectangle is B. These 2 points can't be on the same side of B, because then we'd have something that looks like this. Okay. So what could we have? Well, they could be on opposite sides, in which case, then, we're going to get something like this, or like this, where the parallel sides go into each other. And you can see you're not going to get another intersection on these sides here. on the purple side. Okay? So that's one possibility. They could be on opposite, or they could be on adjacent sides, in which case they come together to form a corner. And you can see if we play around extending these lines, our rectangle is never going to get back to the purple side again. So that's our reasoning. A little bit of casework. You can probably make this a bit more rigorous, but I don't really care. It's part A. It's question 10. These are supposed to be the easy ones. But there's a bit more of a reasoning as to why it can't be 12. You can really only get 2 points of intersection per side of A. Okay? So our answer is D. And that does it for part A. Now we're going to be moving into part B, where each question is worth 6 marks. I will see you for question number 11 in the next video. Thanks for watching.